In this lesson, we will discuss personal loans and simple interest. So, if you need to borrow money, you may need to consider different options for your loan. So, understanding the cost of borrowing money will help you make informed, wise decisions about your personal finances. So, in this lesson, we discuss different options for borrowing money, and we'll go through a few examples together. But first, I think it's going to be important that we go through some important terminology and terms and make sure we understand what these terms mean. The first term we want to discuss is principal. I'll always try to highlight the word that we are defining. So I've put principal in yellow. The definition for principal is the amount of money a bank or other lender is willing to lend a borrower. So if you take out a loan for $10,000, then the principal is $10,000. Also, in certain contexts, the principal is how much you invest. So it's not always about how much you are how much you are borrowing. Sometimes in other contexts, it could be how much you are investing. But in this lesson, we're talking about loans. So also, the principal is sometimes called credit extended. Next is security, sometimes called collateral. This is anything of value pledged by the borrower that the lender may sell or keep if the borrower does not repay the loan. Examples are a mortgage of a house or a car title, a savings account, or stocks, etc. A cosigner is one or more persons who guarantee the loan will be repaid by the borrower. A personal note is a document that states the terms and conditions of the loan. So we'll pause the definitions and terms here for a moment, to talk about one of the most common ways for people to borrow money is through an installment loan or a credit card. We'll talk about that in another lesson, but the concept of simple interest is so important and foundational for understanding installment buying. And so let's talk about interest, and specifically simple interest. So, interest, the definition for interest for us is the money the borrower pays for the use of the lender's money. So simple interest, this type of interest is based on the entire amount of the loan. That's important for the total period of the loan. And then we have a formula that calculates the amount of interest that has accrued over time. The formula is the product of three different factors: the principal times the rate times the time. In short, I like to write my formula like this: I for interest is equal to principal times rate times time. Okay, I don't know why the P is capitalized. That's how I usually write it. It doesn't have to be capitalized. That's not important. But here, let's see if I can. All right, so I stands for interest. P is the principal, which is the amount of money borrowed, remember, or loaned. R is the rate, and the rate of interest, this is a decimal, but in the applications that you and I will look at in just a moment, the rate is always given as a percentage. You and I, when we actually do our calculations, we will convert that percent to a decimal. And then time, and this is time in years. Now, well, most of the time it's in years, but let me say it like this: the time is always expressed in the same period as the rate. For example, if the problem says 2%, which is the rate, if it says 2% per month, then time must be expressed in months. If the rate says 2% per year, which is most of the time, that's what it's going to say, then time is in years. Okay, so let's just be careful about reading the problem and determining what time is measured in. Are we talking about days? Are we talking about months? Are we talking about years? And I'll tell you that most of the time it's in years, but let's be careful to make sure that we just read very carefully. All right. Now, what's really important to note is the most common type of simple interest is ordinary interest. Ordinary interest. And when computing ordinary interest, we will use something called the banker's rule. The banker's rule means that we're going to assume that a month is 30 days, a year is 12 months, and therefore a year has 30 days times 12 months would give you 360 days. Okay, so this is really, really important. So for our textbook, whenever we're calculating simple interest, we will assume that is using ordinary interest. Okay, that's the type of simple interest that we're talking about, ordinary interest. Okay, so we use the banker's rule whenever we're talking about ordinary interest. Whenever they ask us to calculate simple interest, we're assuming they mean ordinary interest. All right, so please remember 30 days in a month, and we know that not every month has 30 days, right? But we're assuming the months have 30 days, and therefore there's 360 days for a year. So this is banker's rule. All right, cool. I think we're ready for our first example. Let's take a look. All right, here we go. Paul needs to borrow $8,500 to replace the deck at his home. From his credit union, Paul obtains a 30-month loan with an annual simple interest rate of 4.9%. Calculate the simple interest Paul is charged on the loan, then determine the amount, which is principal plus interest, Paul will pay the credit union at the end of the 30 months to pay off his loan. All right, first of all, please note certain very, very important items or information that is given in this problem, and disregard information that is irrelevant. All right, so what is really important is this number here, $8,500. This is how much Paul needs to borrow. And so for you and I, this is the principal, right, that Paul is borrowing. That's P. Paul obtains a 30-month loan. So this is time right here. Well, let me circle not just 30, but 30 months. Okay, that's time. With an annual simple interest rate of 4.9%. So this is R. A little sloppy here. That's an arrow pointing at the percent, and then time is right here, 30 months. So we have P, R, and T here. All right, so the first thing we're going to do is calculate the simple interest Paul is charged. So we want to use our formula for simple interest. So what we do is we take the principal, which is 8,500, and I want to multiply that by the rate. Now, in order to change a percentage to a decimal, here, let me show that really quickly, just in case we need a reminder. Now, 4.9%. Now, the word percent means per 100, per 100. And so this is 4.9 per 100. And so what we do in order to change this to a decimal is we multiply, we divide, not multiply, we divide by 100. That's the per 100, right? And what this does, it basically just moves your decimal twice to the left. So if you take this decimal here, and just move it twice to the left, then we will have point, let me get my red back up here, 0.049. This is 4.9% as a decimal. So now I can go back to my formula here, and for the rate, I'll put in 0.049. I don't necessarily need the 0 here in the ones place. I just put 0.049. Times, and now here we have to think about 30 months, okay? Now remember that this is 4.9%, but the wording here is annual. So this rate is per year, okay? Per year. So the number that goes here is time. Let me see if I can, there. The number that goes right here is time, of course, right? That's what T represents. But time in terms of years. So 30 months. So in other words, what is 30 months in terms of years? Well, banker's rule, right? There's 12 months in a year. And so what I'll do then is I'll just put 30 over 12, right? Because there's 12 months in a year. All right. This happens to be 2.5. Your calculator will tell you, or if you just do this by in your head, this is equal to 2.5. 12 goes into 30 twice with 6 remaining, and so 6 over 12 is the 1/2. Anyway, this is 2.5. Okay, so this is the formula, and if you calculate this, this is going to give us. And now, of course, we're talking about money. Let's not forget units here. Let me see if I can create some space here. Yeah, don't forget the dollar sign. Because we're talking units, and units are extremely important. And so we have use your calculator, but 1,041, and then always round when we're talking about money, always round to the nearest hundredth, which means to do 2 decimal places because that's to the nearest cent. So this is $1,041.25. Now let's be careful about what this represents. This represents how much interest Paul is going to pay this credit union. Okay, of course, Paul needs to pay back the $8,500, right, that they're loaning him. But in addition to the $8,500, he's going to have to pay $1,041.25 in interest alone. Interest alone. Now, that's the answer to the first part. Now, the second part, determine the amount. That means the total amount he's going to have to pay back, which is the principal, $8,500, plus the interest, which is right here that we just calculated. So the amount, I'm going to use capital A here for amount, is going to be the principal plus the amount of interest that has accrued. So the principal is $8,500. That's how much he was loaned, plus $1,041.25. Notice that I am omitting a unit here in this line of work, but I'm never going to, hopefully, never going to forget my units for the final answer. Okay, so adding these two amounts gives me, Paul's going to have to pay $9,541.25 back. This is the total amount that will be owed by Paul at the end of 30 months. All right, a new question. Martha agrees to lend $850 to her friend Joe to help Joe travel to Cincinnati to attend a family wedding. 9 months later, Joe repaid the $850 plus $51 interest. What annual rate of interest did Joe pay to Martha? I always find this example or examples like this kind of humorous. You know, if they really were friends, I don't know. I don't know how you feel, but I feel like if I'm going to lend a friend money, I probably wouldn't charge my friend interest. But, you know, maybe this is a different kind of friendship. I don't know. I don't charge my friends interest when they say, you know, can I borrow some cash? But regardless, that's the situation here. Now, let's be very careful about what is being asked here. In the previous example, we did not know the interest. In this example, we do know the interest. Joe is paying $51 in interest. What is not known here is the rate. So that's what we're looking for. All right, so let's do it, folks. So let's use our simple interest formula. I equals to PRT. And so the interest is given, that's $51. The principal is given, it's $850, times the rate, which is unknown, so I use R for the rate, times time. And time here is 9 months later, right? Now, you can see the word annual here. That means per year. So we're talking about years. So 9 months out of 12 months total, right? Which, of course, is 3/4 of a year, right? You can simplify 9 over 12 to be a fraction, to be 3/4, or you can write it as a decimal as 0.75. Completely up to you. And so this is 51 is equal to, now, if you write this as 0.75 and multiply by 850, or if you just do some fraction work in your mind, all up to you, at the end of the day, you get 637.5 times R. Okay. Now, in order to isolate R, we're going to have to use the inverse or opposite operation. And the operation between R, our variable, and this constant multiple here is multiplication. This is 637.5 times R. The opposite of multiplication is division. And so what we're doing here is dividing both sides by 637.5, like that. Okay, so what that's going to do is isolate R, and going to give us R is, use a calculator here, 0.08. Now, in order to change this to a percent, I was mentioning earlier, this is the context where you multiply by 100, right? Because percent means per 100. And so what we do is we multiply by 100, but what that's going to do is move your decimal just twice to the right. And so your rate as a percentage is 8%. So this is the annual rate of interest that Joe has to, that Joe is paying, right, to Martha, 8%. Cool. All right, example 3. To obtain money to pay some medical bills, Genesis decides to pawn his bicycle. Genesis borrows $300 and after 30 days gets his bicycle back by paying the pawnbroker $355. What annual rate of interest did Genesis pay? So once again, the rate is unknown. Okay. All right. So this is using our formula again. So I equals PRT. All right. So first of all, we have to figure out the interest. Now, the interest is not explicitly given, but you and I can figure it out. So if Genesis paid the pawnbroker at the end of the story $355 to get the bicycle back, and initially borrowed $300, that means the interest must be equal to $355 minus the initial $300, right? This is the total amount paid minus the principal, must reveal that the amount of interest that Genesis paid is $55 in interest. Okay, so that is not explicitly given, you know what I mean? They don't say, by the way, the interest is $55. You and I have to kind of figure that out. So that's going to go in for the interest. So we have 55 there. That's a sloppy 55, but 55 is equal to the principal, which is $300, right? That's the loan amount, times the rate, which is unknown, times the time. Now here, let's see, what annual rate, right? This is per year, okay? Annual rate. See, I told you that the rates are usually in terms of years. Now, they told us 30 days later. Now, we know that according to Banker's rule, there are 360 days in a year by Banker's rule. So this is 30 days out of 360. which is equivalent. Like if you wanted to simplify that, you could, instead of using that fraction, you can say this is 1/12. So it's like 1 month out of a year, because there's 30 days in a month according to Banker's rule. So you could replace 30 over 360 by 1/12 if you'd like. Okay, so let's do this. So then this is 55. I'm coming down here, okay? 55 is equal to, and if you do your calculations, and this is 25, the product of 300 and 30 over 360, or 300 times 1/12 is 25. Times r, of course. R is our unknown. So in order to, let me move up a little bit here. In order to isolate r, we will divide both sides by 25, because division is the inverse operation or opposite operation of multiplication. So then the rate is 55 divided by 25, which is 2.2. Of course, to change this number to a percent, we multiply by 100. So as a percentage, when you multiply by 100, remember what that does is it moves this decimal twice to the right when you change a decimal to a percentage. So this is a very high interest rate. So this is 220%, which, if I'm Genesis, then I want to get my bike back as soon as possible, right? I want to pay off this loan very soon, because this interest rate is so high. I'm getting charged so much in interest for every day that passes. So it's in Genesis's best interest to pay off this loan as soon as possible. Okay, now we move into something slightly different. So in the previous examples, those were simple interest loans, where the interest and the principal are paid on the due date, of the loan, the due date of the note. But another type of loan is a discount note. This is where the interest is paid at the time the borrower receives the loan. So you have to pay the interest immediately. The interest is charged in advance, and this is called a bank discount. An example of this would be the Federal Reserve Treasury. That bill is a bank discount note issued by our government, right? And so let's look at some examples of a bank discount. All right, here we go. Sergio took out a $500 loan using a 10% discount note for a period of 3 months. All right, this is everything that they're asking us to find. It's kind of a lot. Determine the interest he must pay to the bank on the date he receives the loan. Determine the net amount of money he receives from the bank. And determine the actual rate of interest for the loan. All right, to get started, let's use our formula for simple interest. Okay, now we know that the principal amount is $500. Okay, times the rate, it's 10%, that as a decimal is 0.1 or 0.10, okay, for a period of 3 months. All right, so then this is going to be 3 over 12, like that. So this is $12.50. So what this is this is the amount of interest that Sergio has to pay in advance. So in order to even process this loan and to get this money, Sergio needs to pay the bank $12.50. So this is called the bank discount for the loan. Now, because Sergio has to pay this, I'm moving the screen up a little bit. So that's the answer to the first question. The answer to the second question, I'll change colors here. Now, because Sergio has to pay $12.50 in advance, then the net amount that Sergio receives will be $500, right? minus this like fee, if you will, this interest that he must pay in advance. So the net amount that Sergio gets to walk away with, right, from the bank is $487.50. I barely fit that on the screen there. All right, that's the net amount because he had to pay $12.50. So the bank is basically saying, okay, here's $500, but we're going to keep $12.50 from that of interest, and we're going to get that interest right off the top. Okay, now the last question says, determine the actual rate of interest for the loan. So in order to calculate the actual rate of interest charged, we use some of this information that we just found. So first of all, I know the bank quoted him 10%, but it's actually going to be higher than that. So let's show how, all right? So let's go here. Okay, let me get a new color. How about red? All right, for the third question. So let's start here again. Now, we know how much interest Sergio had to pay is $12.50, so we can plug that in for I. Let me make that a little neater. All right, $12.50 is equal to, now, the principal amount is going to be $487.50, right? This is the amount that Sergio actually received, right? Actually received. Now, I know it's a loan for $500, but he didn't get $500. He actually walked away with $487.50. That's the actual amount for the principal, times the rate, which we don't know. I know the bank quoted him 10%, but what's the actual rate is what the problem is asking for. And the time is 3 months, right? I think it's 3 months. Yeah, it was a period of 3 months out of 12 months. Let me make sure about that time. I have that right? Yeah, period of 3 months. All right, I don't mean to make you dizzy here. All right, so let's do this calculation. So $12.50 is equal to, remember, 3/12 is the same thing as 1/4, so you can write this as 0.25, right? If you'd like. But at the end of the day, the calculator will tell you it's 121.875 and then times R. So of course what we're doing right here is dividing both sides by 121.875 in order to isolate R. And our rate is 0.1026. Now, to write this as a percentage, remember you multiply by 100, which just moves your decimal twice to the right, like that. So then the actual rate of interest is about 10 let's round to the nearest tenth. So instead of saying 10.26, let's round 2 up to 3. So 10.3%. The bank quoted him 10%, but it's actually higher because the principal, the amount that he actually got, is less than 500. Okay? And so it's actually 10.3%, which is the actual rate of interest, instead of the quoted 10%. That's interesting. I like that. Check out this example. I like this problem. Rodney owns a farm. He needs to purchase new equipment for the farm, but does not have the $1,600 purchase price. So the equipment dealership has 2 payment options. Option 1, Rodney can pay $800 as a down payment and then $850 in 6 months. Option 2, Rodney can pay $400 as a down payment, so that's less money down, but then pay $1,380 in 9 months. Which option has a higher annual simple interest rate? All right, let's look at option number 1. All right, option number 1, I equals PRT, right? That's our formula. I always write it down over and over again, even when I'm working, it helps me memorize. Okay, so how much interest do we have here? Well, we're going to have to figure that out. We're also going to have to figure out how much is the principal. Let's start with principal. So with option 1, Rodney pays $800 as a down payment, right? You just right away, $800. The total purchase price is $1,600. So $1,600 is the total price of the equipment minus what he has to pay as a down payment immediately. That leaves you with, or leaves Rodney with, of course, $800 that he owes. So that is the principal amount. That's like the loan amount. It's like, well, you have to pay us $800 right now. That leaves a balance of $800 that you owe us, the equipment dealership, right? So the equipment dealership is basically saying, we're going to loan you $800. So this is your principal. Okay, this is your principal. Or Sergio's, or who is this? Rodney. Rodney. Sergio was from another problem. Rodney's principal. Now, what about the interest? Okay, well, the interest, notice that Rodney has to pay $800 as a down payment. Plus, for the option number 1, he has to pay $850 in 6 months. So the down payment of $800 plus $850 in total, that means he's paying $1,650. That shows me that the interest then is the total amount, $1,650, minus the equipment price, the purchase price of $1,600. That shows me that he's going to have to pay, Rodney's going to have to pay $50 in interest, right? $50 in interest. So now we have found, I think, everything we need. All right, so $50 is interest. Principal is $800. We don't know the rate. That's what we're looking for. And time for this first option. Remember, the first option is 6 months. So 6 months out of 12 months in the year. So that's 1/2. You can write that as a decimal if you like, 0.5. So a little bit of algebra here. 800 times 1/2 is 400. R, of course, what we're doing here is dividing both sides by 400 to isolate R. And 50 divided by 400, the rate here is 0.125. As a percent, remember we need to multiply by 100. So for option number 1, the rate is 12.5%. That's for option 1. Now let's talk about option 2. Now for option 2, remember it's $400 as a down payment, right? So the purchase price of the equipment is $1,600 minus what Rodney has to pay as a down payment. That leaves you with a balance that you owe the equipment dealership, $1,200. So in option number 2, you owe, or not you, right? Rodney owes $1,200 to the equipment dealership. So this is Rodney's principal. This is how much they're basically loaning him. Now, what about the interest? Well, the interest, notice that Rodney is paying $400 as a down payment. Plus, an option 2 says that Rodney's going to have to pay $1,380, I believe is what it is. Yeah, in 9 months. So in total, Rodney is going to have to pay what is this? $1,780 at the end of the day, at the end of the story. He's going to have to pay $1,780. But wait, the equipment price is $1,600, right? And so if he's paying $1,780 at the end of the whole story, minus the equipment price of $1,600, that shows me that Rodney, under the second option here, is having to pay $180 in interest. All right, so this is Rodney's interest. So let's go for it. So 180 goes in for I. The principal is 1,200. That's a bigger principal, right, than the previous option. That's also more interest than the previous option. But the nice thing about this option is it's less of a down payment, right? Maybe Rodney doesn't have that much cash for a down payment. This option might be good for him. All right, times the rate, which we don't know. The time in this option number 2, it says in 9 months. 9 months. So 9 months out of 12. Again, as a decimal, this is 0.75. All right, so let's do some algebra. So 180 is equal to 1,200 times 0.75 is 900 times r. And of course, our algebra says divide both sides by 900 in order to isolate r. So then r is equal to 180 divided by 900, which is 0.2. As a decimal, excuse me, that is a decimal. As a percentage, multiplied by 100, which would give a rate of 20%. 20%. Therefore, option 2 charges a higher annual simple interest rate than option 1. Option 1 was 12.5%. I can scroll back up. There it is. There's the rate for option 1, and option 2 is significantly higher. Option 2 has a rate of 20%. So the benefit of option number 1 is that interest rate, right? You're going to pay less in the end, right? But I'm trying to scroll down here. Yeah, there it is. At the end, for option 1, Rodney's paying $1,650, right? With a much lower interest rate. That's awesome. The downside of option 1 is that Rodney had to pay a hefty down payment, $800. Option 2, the benefit is, you know what? You don't have to put as much down. You only have to put $400 down. The downside, you're going to have to end up paying much more in interest because the interest rate, the rate here is much higher. Rodney has some decisions to make. Now we look at something called the United States Rule. The United States Rule states that if a partial payment is made on the loan, interest is computed on the principal from the first day of the loan until the date of that partial payment. The partial payment is used to pay the interest first, and then whatever is left over from that partial payment is then used to reduce the principal. The balance due on the date of maturity is determined by computing interest due since the last partial payment and adding this interest to the unpaid principal. Now, a borrower can pay as many partial payments as he or she wishes. This process is just repeated. Let's keep in mind that a partial payment is a payment that is less than the full amount owed and made prior to the due date. This is the United States Rule, is a decision that the Supreme Court made. It's a decision that specifies the method by which these payments are credited. So we're going to look at some more problems, but it's going to be so important that you open our textbook to page 588 and look at table 10.1. It talks about the days in each month. This table is used to determine the exact number of days in a period. Okay, so please reference that table. All right, here we go. Determine the due date of a loan made on April 7th for 180 days, and then determine the number of days from March 15th to November 18th. These are two kind of separate questions. So let's look at the first one. So a loan was made on April 7th, and the loan is for 180 days. And we want to know the due date. So the first thing we're going to do is we're going to look at the table called 10.1 in our textbook on page 588. What we're going to do is we're going to locate, because this loan was made on April 7th, we're going to look for day 7. Okay, so this date is the 7th day of the month. So look at the table, locate day 7 in the far left column, and then move directly to the right 4 columns to the April column. When you do this, you can see in the table that April 7th corresponds to the number 97, which means April 7th is the 97th day of the year. So then what we'll do now, since this is a 180-day loan, we'll add 180 to 97, which gives us 277. Now, when you look at the table again, the table shows that the number 277 corresponds to day 4 of October. So therefore, the due date for this loan is October 4th. Now, what we want to do is answer the second part of this question, which says to determine the number of days from March 15th to November 18th. Now, again, looking at our table tells us that March 15th is the 74th day of the year, while November 18th is the 322nd day of the year. So, to determine the number of days from March 15th to November 18th, all we'll have to do is to find the difference between these two numbers. That difference being 248. Therefore, the conclusion, the number of days from March 15th to November 18th is 248 days. All right, cool. Let's look at this next problem. Using the banker's rule, remember that the banker's rule means that there are 30 days in a month, there are 12 months in a year, and 360 days in a year. All right, we need to determine the simple interest that will be paid on a $2,700 loan at an interest rate of 2% for the period of March 15th to November 18th. Okay, first of all, we need to note that the previous example that we just came from, we just determined that the number of days from March 15th to November 18th is 248 days. So I'll be using this value in our formula being I equal PRT. Remember that? All right, so we're calculating simple interest. So the principal is $2,700. That's how much the loan is for. That is the number 2,700. Sorry, that's a little sloppy. The rate is 2%, which as a decimal is 0.02. Remember, to change a percent to a decimal, you divide by 100. And then the number of days is 248 days. Now that's 248 days out of 360 days in a year. Okay? Okay, so I'm hoping you're using a calculator to determine that the interest is $37.20. All right, I like this problem a lot because it describes a borrower that wants to pay back part of a loan before the due date. Okay, so this is an example that illustrates how a partial payment is credited under that rule by the Supreme Court called the United States Rule. So making partial payments, remember, it reduces the amount of interest paid and therefore the cost of the loan. So it's in your best interest to make partial payments. All right, so here's the example. And this is our last example of the lesson. Kelly is a math teacher and she plans to attend a national teachers conference. All right, to pay for her airfare on November 1st, 2018, she takes out a 120-day loan for $400 at an interest rate of 12.5%. Now, Kelly uses some birthday gift money to make a partial payment of $150 on January 5th, 2019. She makes a second partial payment of $100 on February 2nd, 2019. All right, so there's a list of things they want us to determine. First, find the due date of the loan. We'll do that first. And then we'll determine the interest and the amount credited to the principal on January 5th. Remember, January 5th is where she made a partial payment of $150. And then she made her second partial payment on February 2nd. So we want to figure out the interest and the amount credited to the principal on February 2nd. And then finally, how much will Kelly owe on the date of maturity? All right, let's knock out the first one, the first question. In order to determine the due date of the loan, what we're going to have to do is look at that table again, 10.1. That's the name of the table in our text book. And find November 1st. November 1st is the date that she takes out this loan to pay for her airfare. Find November 1st on the table. And I hope you're able to find that November 1st corresponds to the number 305. That is to say, November 1st is the 305th day of the year. And then what we'll do is we'll add 120 to 305. Why 120? Because that's how many days this loan is for. Remember, that's in the problem. 120-day loan. All right, so we get 425 when we add 305 and 120, which will extend into the next year, right? I mean, she took out this loan on November 1st. And so it was already toward the end of the year, right? And so a 120-day loan 120-day loan will extend into the next year. So what we're going to do is we're going to subtract 365 from 425. Which gives us 60. Now look back at the table and find the 60th day of the year. The 60th day of the year, according to our table, is March 1st. So this definitely answers the first part of this question. So we know the due date of the loan. Now, find the interest and the amount credited to the principal on January 5th. Remember, January 5th is the date of that first partial payment. All right, so from the table, January 5th is the 5th day of the year. We can figure that out even without a table, right? And November 1st is the 305th day of the year. So what we need to do is we need to figure out the number of days from November 1st all the way to January 5th. All right, so this is how we're going to do that. There's 365 days on that table, right? On that table in our text. Minus 305. Okay, this gives us a difference of 60. This number 60 represents how many days from November 1st, the date of the loan, when the loan was taken out, until the end of the year, right? From November 1st until the end of the year. That's 60 days. But you have to add on 5 more days that extended into the new year until January 5th. So basically, there are 65 days from November 1st until January 5th, until the date of the first partial payment. So we're going to use this number, which represents the number of days from November 1st to January 5th, in our formula for calculating interest. So let's do that now. All right. So here we go. Interest is equal to the principal. The principal is $400. That's how much the loan was for. The rate is 12.5%, which is 0.125, and 65 days from the start of the loan until the date of the first partial payment, which is January 5th. Now, according to Banker's rule, there are 360 days in a year. Now, be careful, you're using the Banker's rule there, right? So, doing this calculation using a calculator will determine that the amount of interest that Kelly has to pay on January 5th is $9.03. That's how much interest is due on January 5th. Now, remember, on January 5th, Kelly is making a $150 partial payment. $150 partial payment on January 5th. From that $150, she needs to first pay this interest. So let's do some math here. All right. So she's making a $150 payment. All right, here it is. So $150 payment, but she must subtract $9.03 from the interest. That's how much she has to pay in interest. And so the balance of her payment is $140.97 that goes toward the principal. Okay? So again, this amount, $9.03, that's how much interest she has to pay on the date of her first partial payment, which is January 5th. And this is the amount that is credited toward her principal. So if $140.97 is going toward her principal, that means her principal is going to change. Her principal used to be $400, but $140.97 is going toward that principal, bringing it down to a brand new reduced principal amount of $259.03. This number is very important. This is the new principal. No longer does she owe $400, right? She now owes $259.03. That's really important. All right, let's go to the next question, the next part. The next part says to determine the interest and the amount credited to her principal on the date of her second partial payment, which was February 2nd. February 2nd. All right, so the first thing we need to do, is determine the number of days from January 5th to February 2nd. How many days from the first partial payment to this second partial payment? So we got to look at our table. Okay, according to our table, there are 28 days from January 5th to February 2nd. We know that because January 5th is the 5th day of the year, and February 2nd is the 33rd day of the year. So all we need to do is subtract these two numbers. We need to do 33 minus 5, which gives us 28. 28. So in other words, there's 28 days from January 5th to February 2nd. This will go into our formula for calculating interest. All right. So actually, let me leave it like that. All right, let's fit this in here. Here's our formula. All right. How much interest? Here we go. Our new principal is $259.03. Don't use the $400. That's no longer the principal because Kelly made a partial payment. Times your rate, 12.5%, which is 0.125, times how many days from January 5th to February 2nd, which is 28. Banker's rule here, divided by 360 days in a year. So how much interest now? This will be $2.52. This is how much interest Kelly will have to pay now that has accrued from January 5th to February 2nd. So when Kelly makes a $100 partial payment, $2.52 of that payment goes to interest. So she makes a $100 payment, but $2.52 goes toward the interest, leaving $97.48 to go toward the principal. So now our principal is coming down, right? Our principal was, let me see if I can write this out here. So our new adjusted principal, $259.03, right? Minus $97.48. And so now the new principal is $161.55. So as of February 2nd, this is the new principal. Now this value is important now. Okay, and it's going to help us figure out the answer to the last question, which is how much does Kelly owe on the date of maturity, the maturity of this loan, which is March 1st. Remember, that's the due date of the loan, March 1st. Let's figure out how much Kelly owes. All right, so we need to first determine the number of days from February 2nd, the date of the second partial payment, to March 1st, which is the due date of the loan. So according to our table, March 1st is the 60th day of the year. And February 2nd, we already determined, is the 33rd day of the year. So there are 27 days from February 2nd to March 1st. All right, so let's go to our formula. So our formula for interest is PRT, of course. Now, our new principal is $161.55. No longer the original $400 because Kelly has made some partial payments. Our rate is 12.5%. And we put the number 27 over 360 according to Banker's rule. So on the date of maturity, on March 1st, the due date of the loan, Kelly owes $1.51 in interest. So how much does Kelly owe on March 1st? Well, Kelly owes the remaining principal plus interest. So Miss Kelly owes $161.55 plus $1.51 in interest, which gives her a grand total on March 1st of $163.06. This is how much she's going to owe on March 1st. What's really cool to note is that had Kelly only made that first partial payment on January 5th and that's it, she would have owed more money in the end. She would have owed more money in the end. So then it was in Kelly's best interest to make partial payments. I guess the more the better, because your principal goes down and you're paying less in interest.